Hello, and welcome back to another video. Today, I'm going to be showing you how to implement Basic Auth, Bearer Auth, and password hashing. The first thing that we'll want to do is create a .env file that has the following variables: database URL, which is your connection to your remote database; JWT secret, which is the encryption key for our JSON web tokens; and hash secret, which is the encryption key for our password hashing. Next, we'll come over to our cargo.toml, and you can see that we have a number of dependencies here. The first ones are specific to our Actix Web API and database connection. If you haven't watched my previous videos, I suggest that you do that. And then we have specifically in this implementation Chrono for serializing our date-time column values on our SQL database tables. And then in our SQLX features list, we also have Chrono. For the actual auth part, we have these 5 dependencies. Actix Web HTTP Auth. This will handle our Basic and Bearer Auth. Argonautica, which is our password hashing and verifying package. HMAC, related to our password hashing and verification. JWT for JSON Web Token building. And SHA-2, which is also related to the password hashing. Now that we have our environment and our dependencies set up, we can move on to the actual implementation. For starters, we'll come into our main.rs, and you can see here that I have a simple Actix Web API set up with a Postgres database connection. Please note that I am using SQLX here, but the implementation is SQL crate agnostic, so feel free to use Diesel or whatever you want to use. From this list of imports, the ones that are specific to our authentication implementation is the following block: Actix Web HTTP Auth, HMAC, JWT, CERD, and SHA-2. The first thing that we're going to do is import our services that we have yet to flesh out. So you can see that we have 3 routes here. Super simple, they don't actually do anything, but we are going to bring them in right now in order to show you the actual structure for adding them to our config. So basic auth, create article, and create user. Next, we are going to define what our bearer token looks like. So we need it to be serializable, deserializable, and clonable. The actual structure is going to be called token claims, and ours will simply hold the ID of the user. This can be used to hold anything, information about the user, such as permissions or system features that they may have, and yeah. Next, we're going to create the middleware that actually validates the bearer token. So we'll create a function, async function validator, we'll call it, and this will take in the service request. So this is the actual request that is being made to the API, and then credentials. So this is the authorization header for the bearer auth. And this will return a result, which will be the service request. And if it errors, it will be error service request. First, we need to grab our JWT secret from our env file. JWT secret. And if one is not set, we want to exit from the API. Next, our key for validating the token. This will be our HMAC SHA-256. I have to admit that I am not an encryption expert, so I can't go into depth about what this all is doing, but this is necessary. We are creating a HMAC from our JWT secret. And note that it has to be passed in as bytes specifically. So this is an array of U8s. And we will unwrap. The token string, so this is the bearer token from our authentication header, or authorization header. And we are just calling credentials.token. So this actually pulls it from the auth header. Next, we're going to verify that the token is valid. If it is, then we will store it. Store the token claims object that is located within the token, and if not, then we'll error out. So the claims, which will be a result token claims with a string reference in there, token string, and we will verify with key. And the key is our JWT secret. And if it is invalid, then error out. Perfect. Now that we have our result with our claims, we need to match it. So we need to pull the value out if it exists, and we will add it to our request. So the way to do this in JavaScript, it's super easy. You just add another property onto the request object. In here, we need to use the extensions nut value that they have on there for actually sending custom data through the request. And we insert the value, which is the token claim object. And we return the request. So we send the request on its way to continue onto the route that it was set up to hit. And then we will also handle the error. To do this, we build the config object that tells the authentication error from Actix Web HTTP Auth what the error actually is for and what scope it pertains to, so which group of routes it pertains to. So rec.appdata, and this is a specifically a bearer error related to the bearer token. And the scope in our particular case is just the default, so it'll be like localhost 8080/route. You can use scopes as a group of routes, so like you could do /protected/route or /API/route, and it's an easy way to group. But this, in this case, specifies that this error is for this scope. And finally, we need to send the error on its way. Authentication error from the config that we just created, and convert it into a standard error. And then also return the request. Now that we have our middleware written, we need to add it to our API configuration. So we'll come down to our main function, and within this HTTP server closure, we are going to define our bearer middleware, and this will use HTTP authentication bearer, and we will pass in our validator function. On our app, we will now specify our 3 routes. The first one will be Basic Auth. So this will be like the login route. The next one will be Create User. And the next one will be actually a group, so a grouping setup. And this will have the scope of index as we specified up in our validator function. In order to add the bearer middleware, we need to use this .wrap and pass in the middleware of choice. And then we add our affected routes. In this case, it'll be create article. And that takes care of our main.rs configuration setup. Now let's begin implementing our service routes one by one. So we'll go over to our services.rs file, and we will need the following imports. From main, we will need app state and token claims. From Actix Web, we will need get and post. We will need data, JSON, and rec data from the web portion. Rec data refers to the extensions MUT that we added to earlier, HTTP response, and responder. From Actix Web HTTP Auth, we will need the basic auth extractor. From Argonautica, we will need hasher and verifier. Hasher creates the password hash, and verifier makes sure that the plain text password sent in basic auth matches the hashed password. From Chrono, we will need naive datetime. This is a datetime that does not have a time zone associated with it. HMAC, we will need HMAC and MAC. JWT, we will need sign with key. SERD, deserialize and serialize. SHA-2, we will need SHA-256. And from SQLX, we will need self and from row. So let's start with create user. The first thing that we need to do is define the body that we are expecting when using post create user. So this will need to be deserializable. And it will just be a simple struct called create user body that has a username and a password. Next, we will define what our SQL query will return after we insert the new user. So this one will need to be serializable and from row. We'll call it user no password because we won't be returning the password, and it will return an I32 as an ID and a username as a string. In the actual route body, we will first, from the request, we will need to pull the body using JSON create user body, and that gives us access to the body of the request. We will pull that body into usability, so body.intoInner. We need to pull our hash secret from our env file. So standard env var hash secret, we called it. And we need to make sure that hash secret is actually set. We need to create a hasher using Argonautica hasher default. And for the actual hash itself, the hashed password, we will use the hasher with the password that the user has sent, using the hash secret that we, with secret key, using the hash secret that we specified in our env file, and hash it. And finally unwrap the result. Now to actually perform the insertion into our database, it will return user no password, insert into users, username, password, values 1 and 2, and return ID and username. We'll bind user.username, the hashed password, and finally fetch the return and await it. And again, I am using SQLX here, but you could just as easily use Diesel or whatever else you want to use. It doesn't really matter as long as you're inserting into the database. Finally, we're going to send back the new user that we have just created. And if there is an error, we will just return that as well as a 500. And that takes care of hashing a password and creating a new user with it. The next step that we're going to take is to allow our user to sign in. So I'm going to collapse the create user function, and just below new user no password, I'm going to define the SQL return for auth user. So again, derive serialize from row, and this will just be called auth user, and when we are querying the database, we want to return the ID of the user, which is an I32, the username, which is a string, and the password, which is a string. In the arguments that Basic Auth accepts, we are going to need the Basic Auth credentials extracted from the request. And in the body, we are going to create a HMAC from our JWT secret. So again, this is an HMAC SHA-256 in this case. We create the HMAC from the bytes of the JWT secret environment variable. And we want to expect that it is actually set. And as bytes. And finally unwrap the result. We're going to extract the username and password from the credentials. So the username is actually called user_ID in the credentials object. And password is just called credentials password. Now, a thing to note, this password is an option, so we have to handle when no password is sent. None, and we want to notify the user that it is an unauthorized request. Must provide username and password. But when we are provided a password, we want to pull the user from the database based on this username, and then verify that the username sent is matches a user in the database, and verify that the passwords match. So match SQLX query as, and again we are returning that auth user from our query. Select ID, username, and password from users where username equals $1. We're going to bind the username that we were given as a string and not a reference to a string. And we are going to fetch one from our database. Now, if we receive a user, that's good. First, we're going to handle the error. So if we didn't receive a user, then that means that the username is invalid, or at least a user doesn't exist that matches that username. Or if we're receiving an error here, it could also just be something went wrong. So that's why I'm using an internal server error here. And we will just send back the error message that we received. But if the user was found in the database, then we need to grab our hash secret from our env, and if one is not set, which it should be, but we want to make sure that we have a hash secret. We need to build the verifier, so the piece that actually validates that the plain text password and the hashed password that we have saved match. So mute verifier equals capital case verifier default. And now we will compare the passwords. So let is valid, this will be a boolean, verifier dot with hash. So this will be the user dot password from the SQL query with password. This will be the password that was sent in the basic auth. With secret key, this is the hash secret that we have in our env. And finally, we will verify and unwrap the result. So again, this will be a boolean. If is valid, then we want to pull the token claims from the we want to create the token claim using the ID that will pass into the JWT. So user.id, we will create the token string claims.sign with key, and this will use our JWT secret and unwrap the result. And finally, send back the newly created token. If it's not valid, then we want to send back an unauthorized saying that they either have an incorrect username or password. And that takes care of Basic Auth. Now that our users can sign in, we need to give them the ability to create articles. So first thing, I'm going to collapse the Basic Auth. And then right up here, just below auth user, we need to create the body structure for the article. So derive deserialize. We'll call this create article body. And we will be expecting a title as a string and a piece of content as a string. Next, we need to define what the structure of the article looks like when it's being returned from the database. So we need to serialize, and from row, the struct will be called article. It will have an ID, a title, content, published by, which is the user that has published it, and published on. This is the date and time on which it was published. And this will be an option of naive date time. And then our create article function will take in three pieces. So the first one is the state, which is the app state that has the database connection information. Rec user, this is the requesting user, and it will be an option pulled from the rec data and specifically token claims that is located within the rec data. And lastly, we need to extract the body from the request. Create article body. Right. And we have the rec user, but we need to validate that it was actually received correctly because it's an option. So first off, if there isn't anything, then we want to immediately respond with an unauthorized, unable to verify identity. But if we are sent a user, or if we receive a user, then we want to access the article body, and insert it. Query as, and we will be returning article from the query. Insert into articles, title, content, and published by the following values, and returning ID, title, content, published by, and published on. You need to bind the pieces of information. So first is article.title, article.content, and finally the user.id. We will fetch one again, pass in state.db, and await. If we receive articles, so if the insertion goes through correctly and returns these pieces of information, then we need to send that back as a JSON, a piece of JSON. Else, we want to let the user know that something went wrong. Internal server error, and again, send back the error. And that takes care of create article. Now, the published on is able to be serialized specifically because we have identified it as a naive date time using the chrono crate, and back in our cargo.toml, our SQLX needs this chrono feature. So if it's not working for you, make sure that you have those two pieces, as well as this SERD feature for chrono. Let's go ahead and fire this up and give it a test run. So we'll open up our terminal and we'll run cargo r-r. And now that it's running, we'll come over to Thunder Client. You can use Postman or whatever you want to use. But you can see here that I have our three calls: post user, get auth, and post articles. So we'll open up post user. In our body, I've got username boxed in and password super secret. If I hit run, we should receive a 200 and the newly created user ID and username. Perfect. Now we'll go down to auth, and in our authentication tab, we'll use basic auth, username boxed in, and password is super secret. If I run this, we should get, perfect, the token that should contain our user's ID in it. And if we go into post articles, then with the body, title, article about Rust, content, super insightful content, we go over to our auth and we have this token placed as our bearer auth token. We hit send, then we should receive back an article with an ID, title, content, published by, and published on. And we do. Perfect. And that takes care of basic auth, bearer auth, and password hashing in Actix Web. I hope this has been helpful. If you found it helpful or interesting, please make sure to leave a like and subscribe. It helps more than you may know. And catch you in the next one. Thank you.